Scientists found a Tyrannosaurus Rex with holes in its jaw, but they weren't from a fight. A microscopic parasite killed one of the biggest land predators ever. It ate through bone from the inside. The T-Rex starved to death, never even seeing the thing that killed it. That wasn't special. That was normal for most of Earth's history, not modern parasites. Prehistoric ones were far worse. Ticks are gross. Mosquitoes are annoying. Tapeworms are nightmare fuel. But ancient ones were brutal. Objectively worse in ways that sound made up but aren't. Jurassic fleas were 10 times bigger than modern fleas. Giant fleas couldn't jump. They just crawled onto dinosaurs. Its serrated mouth drilled 5 millimeters deep through dinosaur skin. Ticks swelled up to 8 times their normal size drinking dinosaur blood. Scientists found one trapped in amber, bloated, frozen mid-meal. Worms learned to drill into shells 480 million years ago. They bore right through and moved in. That strategy worked so well that oyster farms still lose money to those same worms today. For 500 million years, parasites have been perfecting the art of eating things alive. Parasites survived every mass extinction. They outlived the dinosaurs. They will probably outlast us too. The only reason we're not dealing with thumb-sized fleas is because we don't have anything big enough for them to feed on. There's a reason prehistoric parasites turned into biological nightmares. It's not just bad luck. First thing, hosts were massive. Animals that weighed as much as a commercial airplane. Dinosaurs, giant fish. Early mammals, the size of grizzly bears. They had blood, lots of it. Being that big, you can't really scratch yourself properly. A sauropod with a 30-foot neck can't reach its own back. Can't groom itself. Once something latched on, it just stayed there permanently, feeding forever. Second, nobody had evolved real immune systems yet. Early animal bodies didn't know how to fight infection. No medicine, no dewormer for a dinosaur. Stuck with whatever decided to eat you until death. Cambrian explosion 540 million years ago, life got complex. Shells, bones, real bodies appeared. Animals learned to steal bodies instead of making food. Parasite equals sign thief, living off someone else's work. No defenses existed. Parasites could try anything. They got big, aggressive because nothing stopped them. Modern parasites, small and sneaky, they have to be. Too obvious tick gets pulled, too big flea squished. In the Mesozoic, you couldn't just pull a parasite off. They were too deeply embedded, and you had no fingers dexterous enough. With zero pressure to stay small, parasites evolved into monsters. There was no evolutionary penalty for being huge. Evolution doesn't care about fairness. It rewards whatever works, no matter how brutal. For about 300 million years, being a giant blood-sucking nightmare worked perfectly. It was a winning evolutionary strategy. The fossil record proves exactly how terrible they were. We have the evidence locked in stone. Let's go back 500 million years. Oceans everywhere, no land animals yet. Just water and the things that lived in it. Brachiopods, these little shelled animals, sat on the seafloor and filtered food from the water. That was their whole existence. But scientists have found fossils of these brachiopods covered in tiny tubes, little worm tubes all over their shells. At first, scientists thought those worms were just harmless hitchhikers, but they weren't. They were parasites. Infected brachiopods were smaller, stunted, and starving. The worms were stealing their food. The worms had positioned their tubes right at the opening of the shell, where the food current flowed in. They intercepted every meal. They were stealing every single meal before it reached the brachiopod's mouth. The host starved while the worm feasted. A brachiopod couldn't move. It couldn't fight. It just sat there, slowly starving, while the worm stole every meal from the opening of its shell. Scientists have found hundreds of these fossils, all with the same worm tubes in the same spot. This wasn't rare, it was standard. The first parasite in the fossil record, a thief that stole food. Fast forward to 480 million years ago, the Ordovician period. Parasites had a new strategy. Early clams, genus Babinka, had shells with strange marks on them. At first, scientists thought it was damage from after they died. But closer inspection revealed question mark-shaped tunnels drilled right through the shell. Something had burrowed in while the clam was alive. CT scans showed the tunnels were made while the clam was alive. The clam had tried to repair the damage, secreting extra shell material to seal the hole. The clam actively fought the damage, but it was losing. It secreted extra shell material, trying to patch the hole, but the worm just kept drilling. The worms bored into the shell, set up a home inside, and lived there, feeding off the clam. The clam spent all its energy repairing its own house, while the worm slowly ate it. This strategy worked so well that modern worms still do this today. Oyster farms lose millions of dollars a year to worms that drill into shells. We've been dealing with this exact problem for 480 million years, and we still haven't figured out how to stop it effectively. But those parasites were on the outside, you could see them. The next ones went internal. 425 million years ago, there were tiny seed shrimp called ostracods. They swam around, ate algae, normal stuff, but scientists found a fossil with something attached. Then, in England, scientists found a fossil ostracod, a tiny seed shrimp with something unusual attached to its shell. When they looked closer, they realized it was a pentastomid, a tongueworm with tiny hooks on its head, clinging to the outside of the shell. This is the first fossil evidence of tongueworms, a group of parasites that haven't changed much in over 400 million years. Modern tongueworms have evolved to burrow inside the lungs of reptiles, where they live breathing your air, eating your tissue, making themselves at home. Which means this strategy is older than trees, older than insects, and older than almost anything you can think of on land. But my favorite example, the one that really shows how long this has been going on, is the famous lamprey. Scientists have found a lamprey fossil in South Africa from 360 million years ago. This was the Devonian, the age of fish, and this lamprey had a sucker mouth with 14 tooth-like structures arranged in a perfect circle. That ring of teeth latched onto fish and ground through their skin to drink their blood. And here's the thing, modern lampreys look exactly the same. The fossil one actually had more teeth than modern ones because it was better at its job. So for 360 million years, fish have been dealing with vampire worms longer than dinosaurs existed, longer than land animals existed, longer than forests have existed. The lamprey's predatory design was so effective that evolution never bothered to change it. But then some animals decided to leave the water and try life on land. Around 240 million years ago in the Triassic period, life made a permanent move onto land. Fish grew legs, plants spread across the continents, and everything was new and exciting. But the parasites followed, because they don't care where you live. They simply learned to breathe air and came right along, infesting the new terrestrial hosts. Scientists study fossilized poop to understand ancient parasites. Inside these coprolites, paleontologists found parasite eggs preserved for millions of years. One famous coprolite from Thailand, 200 million years old, came from a Phytosaur. Paleontologists sliced open this fossilized dung to see what the animal had eaten. Inside, they found 5 different kinds of parasite eggs. The Phytosaur had roundworms, flukes, and possibly single-celled gut parasites all at the same time. Inside its intestines, a full ecosystem of worms. Roundworms, flukes, single-celled gut parasites all stealing its food, making it sick. There was no medicine, no way to purge them out. It just had to walk around infested with 5 different species of worms in its guts until it died. That's how bad land parasites were right from the start. The second animals left the water, they were already infested with multiple parasites at once. But it gets more specific. We have found older poop from Brazil, specifically 240 million years ago. This one came from a cynodont, which is basically a mammal before mammals worked out all the details. It still had some reptile features. Inside that poop was a single tiny egg, microscopic. When scientists looked at it under a microscope, they realized it was a pinworm egg. Pinworms. The same worms that infest kids who don't wash their hands. The same worms that live in your butt and lay eggs at night and make you itchy. They've been around for 240 million years. They were infecting mammal ancestors before mammals even existed. And the scientists who found this egg named it, I kid you not, Paleoxyurus burni, a real official name published in a journal. Different Brazil poop held roundworm eggs, ascarid nematodes. To get technical, these are the worms that infest dogs, cats, and pigs today. The ones you have to deworm your pets for, that grow several inches long inside intestines and steal nutrients. And here's what really gets me. These hosts were herbivores. They ate plants. That's it. They weren't hunting prey that might have had parasites. They were just eating ferns and leaves. But the worms found them anyway, because parasites don't need an invitation. They'll find a way in. Life on land started with animals already full of hidden worms. Internal worms you couldn't see or remove. Every land animal walking around was probably infected with something. Multiple somethings, in fact. The Triassic was a wormy time. Worms everywhere. Inside everyone. All the time. At least those worms stayed hidden where you couldn't see them. But the Jurassic period said no, actually. The Jurassic made parasites you could see from across the room with your bare eyes. A flea fossil was found in China 165 million years old. Several of them, perfectly preserved in ancient lake beds. They named it Pseudopulex. It was 2 centimeters long, almost an inch. That's 10 times bigger than a modern flea. The size of your thumbnail. It was flat top to bottom pancake style, built to sit on top of skin, not hide in fur. It couldn't jump. Its legs were stubby, normal walking legs with big claws on the end. It didn't need to jump. Its hosts were massive and slow, covered in feathers or fur. Curved, serrated claws hooked into feathers or fur, designed to grip and never let go. But the worst part was the mouth, a 5 millimeter long proboscis lined with backward pointing barbs. That mouth was as long as an entire modern flea, and it had teeth on it. It didn't bite, it drilled. Then it drank. Probably a lot given its size. Fossils from the same site show multiple individuals preserved together, suggesting they infested hosts in swarms. Picture a feathered dinosaur, maybe a small raptor, covered in 20 of these cockroach-sized fleas, each with a serrated drill mouth buried in its skin. You can't swat them off because they're hooked in. You can't scratch them off because their claws are too strong. You just have to tolerate it. This nightmare lasted for at least 40 million years, from the Jurassic through the Cretaceous. But the Jurassic oceans had their own problems. Fish fossils show evidence of parasitic isopods, tongue biters. Scientists have found small crustacean fossils attached near the jaws of Jurassic fish, positioned exactly where a tongue biter would be. Even underwater, you weren't safe. These isopods would replace the fish's tongue, living inside its mouth. Mosquito-like flies started showing up in the late Jurassic. They had the right mouthparts for biting, and later fossils proved they figured it out. Large dinosaurs wading through Jurassic swamps were covered in clouds of biting flies, constantly swarmed with no repellent and no shelter. Then the Cretaceous period arrived and made everything significantly worse. In what is now Myanmar, 99 million years ago, tree sap dripped down and trapped a tick perfectly. The tick was swollen and bloated with blood, about 8 times its normal size. Scientists named it Dinocraton draculae, Dracula's tick, because what else do you call a blood-filled tick from the age of dinosaurs? The tick died while feeding mid-meal, gorged on blood. It got stuck in tree sap and never stopped drinking. Another tick in the same amber deposit was gripping a dinosaur feather, holding on with its legs. This is direct confirmed evidence of a tick on a dinosaur, 100% proof, frozen in amber for 99 million years. That same amber also contained beetle larvae, dermestid beetles that only live in nests, feeding on shed skin and waste. This means ticks weren't just on adult dinosaurs, they were waiting in the nests, ready for hatchlings. Baby dinosaurs would hatch and immediately get swarmed from their first breath of air. There's no safe childhood for dinosaurs, no grace period, just bugs from the moment they were born. In 100 million-year-old amber from Myanmar, scientists found tiny wingless insects with flat bodies and strong chewing mouthparts. They looked unlike anything alive today. They named it Mesophthirus, ancient proto-lice. These were the grandfathers of every louse that has ever made anyone itchy, and they were chewing through dinosaur feathers. Feathers from the same amber show bite marks and holes chewed right through. The damage ruined insulation and made flight harder, a constant, inescapable irritation. But external parasites weren't even the worst part. The Cretaceous had internal ones too, ones you couldn't see, ones that killed you slowly from the inside. Scientists found a biting midge trapped in Cretaceous amber. When they looked inside its body under a microscope, they found cells, malaria cells. Proto-malaria, the ancestor of the parasite that causes malaria. This is proof that blood parasites existed in the Cretaceous. Proof that insects were spreading disease between dinosaurs millions of years before humans ever evolved. Malaria still kills hundreds of thousands of people every year, even with modern medicine. Dinosaurs had no medicine. They just got sick and either survived or didn't. Other amber fossils showed evidence of leishmania and trypanosoma, parasites that cause flesh-eating sores and sleeping sickness. Both were present in the Cretaceous. Dinosaurs were getting infected with microscopic parasites that destroyed them from the inside. They had no concept of germs, no understanding of disease. They just felt terrible and started dying. Then there was a wasp found in amber, built differently from anything alive today. Its abdomen had spiny flaps that could snap shut like a trap. The wasp would wait for a beetle or fly to get close, then snap the flap shut, grab the prey, and inject its eggs inside. The larvae would hatch and eat the host alive from within. Thankfully, that family of wasps went extinct. We don't have trap abdomen wasps anymore. But for millions of years in the Cretaceous, insects had to worry about getting grabbed by a wasp's rear end and slowly eaten from the inside. But the most famous example is Sue, the T-Rex in Chicago. She has holes in her jaw, smooth and healed, not from a fight. Scientists compared the holes to modern birds with trichomonas infections, a throat parasite. The damage matched perfectly. Same smooth edges, same location. It was a microscopic protozoan that ate through Sue's jaw from the inside, causing lesions, making eating painful, and eventually starving her to death. So why don't we have giant parasites today? The answer is simple. Hosts got smaller. Parasite size scales with host size, bigger host, bigger parasite. A flea on a mouse is tiny. A flea on a sauropod had to be huge, bigger mouth to pierce thicker skin, bigger body to store more blood. That's just physics. We're too small now. The giant fleas and drill-mouthed ticks are gone because there's nothing big enough to support them. And those ancient parasites were brutal. No numbing agents, just sawing and drilling. We got lucky.